Welcome back to our lecture on Chapter 4 in Engineering Economic Analysis. We're going to now continue our discussion on uniform series. So we've already discussed a few different factors for a uniform series, and we're just going to continue on with that discussion. So the next type we're going to talk about now is going to be a capital recovery factor. And what this one is it's a factor that's used to calculate our uniform cash flow for each period given a present sum or an initial sum. Okay, so I have P being my present or my initial cash flow or my principal, and A is my uniform cash flow, I is my interest rate, and N is my number of periods. So this formula looks like this, and then the functional notation looks like this, and this then being column 4 in Appendix C. So here I'm going to be looking for an A or a uniform series value given a P or a present value. So all of these examples then are getting pretty similar. You guys are probably getting pretty good at it, and it's probably becoming more intuitive to solve them, but these problems will be very useful in your lives. Okay, so let's look at an example with our capital recovery factor. So you purchased a home for $150,000. The current annual mortgage rates are 6%. If you put $10,000 down as a down payment, what would your monthly principal and interest payment be for a 30-year loan? So this is something that, in my opinion, is extremely useful to be able to calculate yourself rather than having to call some loan officer. So let's go through these calculations. Okay, so using the formula, I'm going to get this, where my P or my present value is $150,000. My I now is a little bit different. So I'm told in the problem that my nominal interest rate or my annual interest rate is 6%. But it's going to be compounded monthly because I'm going to have a monthly mortgage payment. So if I compound that monthly, that then becomes an effective interest rate. So that's 6% divided by 12 months, which would then give me 0.005. So I then solve this using the formula. I plug in all these beautiful values, and I get a monthly payment of $899.33. Okay, so once again, if I compare that with my tables, I plug these values in, and I want to find my factor, which is A given P of 0.5% of 360 months. So be careful now, N became 360 because I want to know what a monthly payment is for 30 years. So N is going to be 12 months per year times 30, which would be 360. So I then get a factor of 0.006, so I get A equals $900. So you can see the formulas in the tables pretty much give us the same values. The tables now are going to start becoming a lot easier to do than the formulas themselves unless you are super fast at this kind of math. So it might just be easier to start using the tables alone. In your calculators, like a TI-80 Plus or the equivalent for a Hewlett-Packard, usually embedded in your calculator are some kind of economic formulas, like you can find your A given P formula or your A given F formula. So you might want to Google or play around with your calculator to see if you can find these formulas or these tables within your calculator. So the next type of factor we have is one called a present worth factor. So you can probably guess what this one's going to be. But this is then used to calculate the present worth given a uniform cash flow. So once again, we have this same variables as before, and this is my formula. So it's just different a little bit. And then my functional notation would be this. I'm solving for P given a uniform value. So P given A, comma I, comma N. So this then is column 6 within your appendix. Okay, so let's look at an example. An investor holds a time payment purchase contract on some machine tools. The investor will receive $140 at the end of each month for a 5-year period. The first payment is due in 1 month. He offers to sell you the contract for $6,800 cash today. If you can otherwise make 1% per month on your money, would you accept or reject the investor's offer? Okay, so this person wants to sell you a contract to own some tools. So either you can pay him $140 at the end of each month for 5 years, or you can give him $6,800 today. All of this is assuming, by the way, that you're interested, right? You're interested in buying these tools. But if this money of yours can be making 1% per month while sitting in the bank, what should you do? What decision should you make? So this is when we use our present worth factor. Okay, so I put this in my functional notation. I plug in my values. So I say that if I pay $140 per month for the next 60 months or the next 5 years, that money then, that $140 per month, would accumulate to become $6,293.70. Versus if I paid him $6,800 in cash today. So in that case, the answer then would be we wouldn't pay him the $6,800 in cash today because that would be more than if I just paid him $140 monthly. Knowing all of these different formulas and factors allows us to be able to make these comparisons with each other.